and I will just explain these things for the recording purpose. So I'm just saying that basically DC string voltage or DC system voltage loss is directly proportional to the uh, power loss. So when they increase the increase the voltage drop loss, they increase directly the power loss. So that is why the IC standard will not allow us 1 to 1.5% higher than that one of the system. So if you talk about the large scale project, when we are working on that, the consultant will not allow us anything higher than 1% in the DC case. But in case of DC string and LVDC, like combiner box case, they will allow us up to the 1.5 or 2% average basis. But in case of DC string and string inverter, they not allow us more than 1% in the DC systems. So that is why we have to follow the IC standard and we have to minimize the DC loss. I have just messaged these website doc88. You should search the IC standard or any standard like the uh, USA standard, IC standard, South African standard, any standard. You should search that, and you will find the latest version of that one, and you will open that one in the English or any in two language available, English and Chinese. You should click the English language and then at the end read full document. You should read that one easily without any payments. So that is why I have just shared that website. And also you should search these IC standard which I have shared in the group 62548 and 62738. In that uh, both standard, they have clearly mentioned that string cable criteria is that the short circuit current of the one cable, one string multiply with the plus 10% bifaciality and plus 50% margin in case of DC strings. But in case of LVDC, they have just uh, changed some things. Like they have just criteria that the short circuit current of one string, including bifaciality, multiply with the number of strings connected in one combiner box with the number of with plus added 25% margin. In case of LVDC, 25% margin, but in case of LVDC DC string, 50% margin. We have to add them to cable size, the proper cable sizing criteria. So I have just explained DC string criteria already. I have started the recording later. That is why I have just repeat that some points, and then we move on to the DC string sizing. I've just already explained that uh, these criteria, like this derating factor, like the same one which we have already I have explained in the LVAC cable sizing criteria. These are the same one, no change in that one. We just have to compare that our original environmental conditions with the actual one which the manufacturer has considered while calculating the ampacity of the cables. Like I have already mentioned that one, like 0.5, 1.2, 25-degree temperature. So that is why our temperature is and our criteria is differ from that one. So we have to apply the derating factors. But in case of DC, we have just only these portion are different. Other thing are same. If we follow the IC 62738, we have to apply this criteria. Short circuit current, including 10% bifaciality plus 50% extra margin there. So I have just made that one, like 20 PV modules per string. Operating voltage, I have already explained that at the time of operation of the system, the voltage or current, they are called operating current. And when our panels in open, they are not connected to anything. We just check through the voltmeter and through the ampere meter. These current and voltage called ICE, open circuit voltage and short circuit current. So the as per the IC standard, we have to follow that one. Maximum short circuit, that including the bifaciality. Bifaciality mean that the back of the PV modules, because in these days we are the manufacturer give us the bifacial PV modules. They will generate the power from front side and also from the back side. So 10% means 10% extra power will be generated through the back side. And this is the IC current. And on that, we have to apply the 50% extra margin there. So this is the current we get, that this current should be less than the derated ampacity of the cables. So if that criteria satisfy, our system cables will be satisfied. Here is the same one. I have just make the tables for the cables, like three cables, 4 mm, 6 mm, and 10 mm cable. Ampacity I should get from the vendors, and also this resistance. Manufacturer, they give us the R20 value. So we have to give the uh, voltage drop at standard test condition. Standard test condition means the 25-degree temperature. So we have to calculate the R25. So as per the IC 60287-1-1, they have given us the formula for the calculation of the DC resistance. So they give us that R20, this resistance multiply with the 1.1 plus uh, alpha 20 temperature coefficients. For the copper and aluminium, they give us in that standard, multiply with the temperature on which we are calculating. Like if we calculate at the 90-degree, we have to add that 90-degree. If we are calculating at 25-degree, we have to add 25 minus 20 base temperature. So that is, here we have calculate that resistance. Here I've just applied these same cables drop down, and then the cable length, then resistance, we apply the VLOOKUP formula like same one in case of LVAC. And ampacity, I same apply the VLOOKUP formula that will take from that uh, cables. When we select that cables, they will automatically check that one, and they give us that ampacity in case. Then the derating ampacity should be that ampacity multiplied with the derating factor which we have calculated on there. And then the voltage drop formula. Voltage drop formula is different from the three-phase 2RLI LI divided by 1000. Why we have considered that 1000? Because 1000 means that we have to change the length, this length, into kilometer, because our resistance in the kilometer per ohm. So when we multiply this resistance value with the length, then we get that resistance in ohm. So that is why we have to change that one. So ohm into current, they will give us the voltage drop. So the voltage drop percentage should be the voltage drop for this divided by the system voltage. System voltage means that operating voltage which we have this consider, because the number of PV module in one string multiply with the operating voltage of the PV module, they will give us the one string open circuit operating voltage. So this is the percentage voltage drop. This runs per phase means that the load current which we have, this consider this one divided by the derated ampacity. If your this maximum criteria current is higher than the derated ampacity, means that we have to either we have to increase the number of runs per phase of the cable, or we have to change the size of the cable, because they are not satisfy the criteria. So here our voltage sorry, current is less than the derated ampacity, so they will give us the 1 runs per phase. And then we have multiplied this derated ampacity with the number of runs. because if we increase the number of runs per phase, the derating capacity should be directly increased. And then we have checked that if the derating capacity is higher than this criteria, then it's true. And then we have to apply the voltage drop criteria like less than 1%. I have already explained that in the 62738, they have clearly mentioned that the DC string voltage or DC voltage should be 1 to 1.5% on average basis. So that is why we have applied the 1%, because in the international market, they will not allow, in case of string inverter, they will not allow us maximum voltage drop should be less than 1%. So that is for the DC string. Now we move on to the LVDC cable sizing. LVDC sizing criteria, all the things remain same. All the remaining, like the derating factor should be remain same. We have to just check that formula and then we have to apply these derating factors. But we have to check like the same one. Like here we have 29 PV modules per PV module per strings. Operating voltage should be like the same one, because in case of parallel string connections, the voltage remains same of one string, but current should be multiple of that number of strings. So here is the maximum short circuit current, that is 17.75. So we have considered the string per combiner box 14 strings, 14 string in one combiner box. That is why the combiner box operating voltage remains same of the one, because we have just connecting the strings in the parallel. And then the combiner box operating current should be multiple of that this number of string, and then the operating current of one string, because one string and one PV module string current should be remain same. So that is why we have multiplied that one. And then the maximum current should be same one like that one, multiply with the number of strings. And then the IC maximum criteria should be 1.25, because as per IC, this I have mentioned that combiner box or subarray current should be IEC plus 10% bifaciality plus 25% extra margin, multiply with the number of strings. So that is why we have to apply this one. This one. Okay. So we have to like same one. I have just mentioned the DC cables current, and then the resistance I have calculated the R25 degree temperature. And here we have just applied the drop down list length measurement, resistance, cable ampacity, and this derated ampacity. Derated ampacity should be multiple of that factor. And then the voltage drop, right, 2RLI, same like one. Voltage drop remain. Now it should be like I have applied the 1.25%, 1.2%. So here is the derated ampacity should be multiple of the runs per phase. Same like one, that this should be the maximum criteria, and this is the voltage drop like the same one. No change in that. Same like that. There is a no change in that one. Okay. So that is why the DC string and LVDC cable sizing remain the same one. That is I just explained to both all of you. So one, in case of the combiner boxes, mostly client will require that the DC string or LVDC voltage drop should be like 1.5% or 2%. They basically standard way mention, not clearly mention that it should be the LVDC, or they should clearly mention the DC system voltage standard as conditions. So most of the consultant will allow us 2%. So how we will calculate that one? The voltage drop of that LVDC cables and the number of strings connected at that combiner box. The average voltage drop of that one, plus the cable LVDC cable voltage drop, that will call the DC accumulative voltage drop. The number of strings, like 14 number of strings, and their voltage, the average voltage drop of that 14 strings should be 0.7 or 0.8, plus the that respective combiner box LVDC cables voltage drop plus that average. It it should be the accumulative. Some consultant will allow us that you should average that 14 string or 15 or 13 strings and then add the respective LVDC cables. But some will allow us that the maximum current of one string, that is the maximum in 14 or 13, what is the maximum current, plus the respective LVDC cables. That should call the criteria. Because IC standard has not clearly mentioned about how we will calculate this in case of DC string and LVDC. So the consultant will like raise their concern, raise their issues, and employer require different things. How they like we have faced that some consultant client will require that it should be 1.5%. Some require that it should be the 2%. So it is like 1 to 1.5 or 2%. It remain in between the DC the voltage drop. Okay, so that is for the today. If you have any question, you can ask. Then we will end up our today class. I think you should have no question, guys. You have not any question. Okay, guys. Allah Hafiz. Okay, Mr. Kazi. Allah Hafiz. Do you have any question?
No, sir. Please share the Excel file.
Okay, 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 okay. Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz.